Hi folks, Mrs. Gates here. In today's lab, we are going to continue to talk about the transfer of energy. If you remember last week, we looked at the transfer of energy from the chemical energy in an ethanol burner to the heat energy as we attempted to heat a beaker of water over the flame. We noticed that we did not have 100% efficiency in the energy transfer. And you guys looked at a lot of different places that energy went besides the heat in the water. You said that some of that energy came out as light. Some of that energy went into heating the air around the experiment, heating the glass of the beaker, or heating the metal stand. In today's lab, we're going to look at heating water in a different way, hoping to increase the efficiency of our process. In today's lab, we are going to use an immersion heater. An immersion heater plugs into the wall and takes electrical energy and turns it into heat. This little guy heats up really hot. We are going to heat up water by putting it in a styrofoam insulated cup and immersing the immersion heater right into that water. As we work through the experiment this week, try and think about why this method of heating water might be more efficient than what we did last week in lab. Let's get started. I have filled this cup with 200 milliliters of relatively cool tap water. Go ahead and take a look at this thermometer to record the initial temperature of the water. Now that we have the temperature, it's time to heat it up. I will take our immersion heater, lower it so that it is submerged in the water, but not touching the styrofoam cup. Plug it in and set our timer for 3 minutes. Ready? Start. We will now unplug the heater, take it out of the water, and read the final temperature of the water. We'll use that to calculate how much heat energy our water gained. In order to calculate the electrical energy that was input into our system, we need to know a little bit about our immersion heater. Can you guys read that? I don't know. What this says is 300 W. What's a W? A W is a watt. That marking is telling us that this immersion heater that we will be using in our lab is a 300 watt immersion heater. What's a watt? A watt is a joule per second. That means that for every second that this immersion heater is plugged in, it's taking 300 joules of energy out of the wall socket and turning it into heat. Remember, we let the immersion heater sit in the water for 3 minutes. That's 180 seconds. So 180 seconds multiplied by 300 joules per second gives us 54,000 joules of energy as the input energy from our electrical immersion heater. In order to compare the energy released by this heater to the energy gained by our water, we are also going to need to convert joules into calories. How? Well, 1 calorie is equal to 4.2 joules. 1 calorie, 4.2 joules. Remember that our immersion heater used 54,000 joules during the 3 minutes it was in the water. To convert this to calories, we will multiply by 1 calorie over 4.2 joules. The joules cancel out, and 54,000 divided by 4.2 gives us 12,857 calories of energy from the immersion heater. Now that you have collected the data from this lab, use it to calculate the energy gained by the water and the efficiency of this energy transfer.